This question on the binomial really threw a lot of you, so it's worth going through this one in a little bit more detail. Hopefully once you've gone through it, you'll see that it's actually just an extension of the skills and understanding you already have, but it can be a little bit difficult to access, and indeed quite a few of you struggle to come away with many points from this. So we are asked to consider the expansion of x squared multiplied by 3x squared plus k over x to the power 8. We're told that the constant term is 16,128, and we are asked to find k. So let's have a look at how we can do this. The key to understanding this is that we have a binomial expansion here. We've got here an x squared term. So there's going to be some term in this binomial expansion which is going to yield us x to the power of some value n, such that when we multiply it by this x squared, it will yield us a constant term which we should recognise is x to the power 0. So hopefully we can recognise, using the laws of indices, that in order to end up with a constant term, the term that we are looking for in the binomial expansion of this 3x squared plus k over x to the power 8 must be negative 2, because if we have a value of x to the power negative 2, or we look at the x to the negative 2 term in this expansion, once we multiply it by the x squared, that will cancel out and give us x equals 0. So the real key to accessing this question is recognizing that what we need to find out then is the x to the negative 2 term in the binomial expansion here. So if we just look at the x terms to start off with then, first of all we've got x squared, and we are multiplying that by, this is going to be x to the power negative 1. So we have got the binomial expression here is the power of 8, so we can recognise that this component x squared we can raise to the power of r, and this power here, x to negative 1, we can raise the power of 8 minus r. And when we multiply that all out and expand it, we know that it's going to have to give us x to the power negative 2, because once we multiply that by the x squared, that will give us the constant term. So first of all, we're going to try and find what r is, and then we can actually substitute it back in to find the coefficients. But let's just start trying to figure out what r is. So if we expand this, we're left with x to the power 2r multiplied by x to the power negative 8 plus r. If we remember, we're multiplying 3 by negative 1 here. That's going to equal x to the power negative 2. And then when we're multiplying, remember the laws of indices here, we're going to add those. So we can say that 2r plus r is going to give us 3r. And then if we take this negative 8 over here, that's going to become positive 8. So we can say that 3r equals 6. So therefore r equals 2. So now we know that r equals 2, we can actually complete the binomial expansion of this section. So our power is 8, so we're going to be looking at 8, choose 2, 3x squared all to the power of 2, because we found previously that r equals 2, and we're going to multiply that by k over x, and that's all going to be to the power of 8 minus 2, which is 6. So if we complete this on our calculator, 8 choose 2 is going to give us 28. 3x squared all squared is going to give us 9x to the power 4. And then this is going to give us k to the power 6 all over x to the power 6. And we can therefore multiply that out, and we'll get 252 k to the power 6 multiplied by, if we've got x to the 4 multiplied by, in essence this is x to negative 6, that will give us x to the negative 2. However, remember, we are multiplying each term in the binomial expansion by x squared. So we would here be multiplying this by x squared. So this x squared and this x squared will cancel out, and this would give us the constant term. This is the expression for the constant term. However, we're told the value of the constant term is 16,128. So we can equate this, 252k to the power 6, we can equate that to 16,128. So we can say, therefore, that k to the power 6 is 16,128 divided by 252, which gives us 64. Therefore, k is going to be plus or minus the 6th root of 64, which is therefore plus or minus 2.